Hey everybody, it's Mrs. Walsh, and this is our second video lesson for Unit 5, where we're going to be looking at similar polygons. Alright, so similarity. If we just did a unit on congruence, so I know you remember this. If two polygons were congruent, the sign would have looked different. It would have been like this, but we knew that each one had to match up with the corresponding. So order really mattered in the way in which we wrote the polygons. The same is true for similarity. We're just using a different symbol. This kind of squiggly tilde thing is the symbol we use for similar polygons. So similar figures are figures that have the same shape, the exact same shape, but not necessarily the same size. So the way I like to think about it is I have a shape and I can shrink it and stretch it proportionally, and I'll still have a similar figure as long as all the proportions are the same. I'm just dilating it with a positive factor and with a fractional factor, stretching, shrinking, but remaining with the same proportions. This symbol means that it's similar to. And two polygons are similar polygons if all the corresponding angles are congruent and if all the corresponding sides are proportional. So you can see the only difference here between congruent polygons and similar polygons, this part's the same. All corresponding angles are congruent is the same in both. The difference is the sides don't have to be the same size like they do with congruent. They just need to be proportional. So when three or more ratios are equal ratios, you can write an extended proportion. And I'll show you what I mean by that. Now, let's say that we had a triangle MNP and a triangle SRT, and we're calling them similar. So, I always told you guys I like to draw these things out. It's better for me if I make it visual. So, you have to put things in the same order, right? So, M has to be congruent to S, N has to be congruent to R, and P has to be congruent to T, because that's the order they were written in. So if I want to know the pairs of congruent angles, angle M has to be congruent to angle S, angle N has to be congruent to angle R, and angle P has to be congruent to angle T. Now, the sides do not need to be equal. They need to be proportional. So that means that whatever the ratio is of side MN to side SR, it has to be equal to the ratio of NP to RT, because these all have to be proportional, and also equal to the ratio of the bottom side PM to TS. So that's the extended proportion for the ratios of the corresponding sides. Alright, so the angles have to be congruent, and then whatever this to this is has to be the same as this to this, which has to be the same as this to this. It has to be proportional. Maybe it was a scale factor of 2, maybe it was a scale factor of a half. Whatever it is, they were all extended or shrunk by the same proportion. Alright, so let's say we have a quadrilateral, and this one is D, E, F, G, and this one is H, J, K, L. Once again, the angles have to match up. 1, 2, 1, 2, 3, 1, 2, 3, 4. Alright, so the pairs of congruent angles, angle D is congruent to angle H, angle E is congruent to angle J, angle F is congruent to angle K, and angle G is congruent to angle L, and it really is the order in which they come, right? First to first, second to second, third to third, and fourth to fourth. And the extended proportion, so D, whatever DE to JH is, it has to be the same as EF to JK, which has to be the same as FG to KL. So I'm just going side to side to side, which has to be the same as GD to LH. Okay, now we've kind of been referring to this scale factor, whatever it is we're using to shrink or stretch our shape. But a scale factor is the ratio of corresponding linear measurements of two similar figures. So in this case, if I look at these, we can see that the angles all correspond. And now we just need to make sure that the sides are proportional. So that would mean 20 to 8 would be, if I just pick two sides, for example, BC and YZ, whatever that proportion is, which is 20 to 8, which simplifies to 5 to 2. That is the scale factor I'm using for all the sides, and you can see that that is true. So that means that 15 over 6 better simplify to 5 over 2, which it does. And that means that 25 over 10, because that's the ratio of this to this, better be that same scale factor, the same kind of proportionality. And once again, that does simplify to 5 to 2. So that's how we know that all of the sides are proportional. We've got the angles, now we just have to make sure that this scale factor, whatever it is that we're using, works for all of the sides, and then that is the scale factor we're using to go from this to this. It's a 5 to 2 ratio. All right, now, if we're being given two shapes and we're trying to figure out if they're similar, step one has to be, do the angles match up? Are they congruent? And M and W are congruent, J and T are congruent, K and U are congruent, L and B. All right, so I've checked off the first one, which is the congruent angles. Now the second piece is all the sides need to be proportional. So the proportion of JM to WT has to be equal to the same proportion, for example, as JK to TU, because this side to this has to be the same as this to that. And let's see if that's true. Well, JM to TW is a 6 to 6 ratio, which is a 1 to 1 ratio. But JK to TU is a 12 to 6 ratio, which is a 2 to 1 ratio. That isn't using the same scale factor. This is a scale factor of 1, this is a scale factor of 2, so no, these figures are not similar. Now, let's look at this one. I've got this angle matching this one, so you have to be careful. For those of you who might struggle visually with this, let's redraw it. That F is here, the D is here, so they're in the same orientation, and the E is down here, and you can see that those line up. But then this helps you tell what side goes with what side. So DF is 10, DE is 15, and EF is 20. Let's see if all of these give us the same scale factor. So is 8 to 10 the same as 12 to 15, which is the same as 16 to 20? Well, 8 to 10 simplifies to 4/5, 12 to 15 simplifies to 4/5, and 16 to 20 simplifies to 4/5. So this is similar, and the scale factor is 4 to 5, or 4/5. All right, now, I know how much you love overlapping figures, so let's look at this overlapping figure. A, B, C, D, they're telling us that it is in fact similar to E, F, G, D. We don't have to say if it is, they're telling us it is. And so we need to find the value of X. Well, I'm going to tell you that I would probably, so that I don't get confused, would redraw this little guy so that I can see that this is 6, and this is Y, and this is X. Well, in order to figure out the scale factor, I cannot use this side because I have a variable, and I can't use these two sides, and I can't use the bottom because they didn't give me a measure. But I can use DE to this whole big AD. So AD to DE should give me the scale factor of the large quadrilateral to the smaller quadrilateral. AD is 9, DE is 6, so we have a 3 to 2 scale factor. Now, to solve for X, I know that BC to FG, which is 7.5 to X, has to be my scale factor. It has to be a 3 to 2 scale factor because they told me it's similar, so I would use the same scale factor for all sides. All right, well, I think the quickest way to solve this is to cross multiply. So I'd get 3x is equal to 15 and x is equal to 5. And we can check that. Is 5 to 2.5, 7.5 to 5, is that a 3 to 2 ratio? And it is. It works. Now we can do the same thing to solve for y. AB, which is 5, to EF should be this same ratio, right? So it's a 5 to y, which has to be a 3 to 2 ratio. Once again, we can cross multiply, and we get 3y is equal to 10, and y is equal to 10 over 3. And you can see that that does end up being a 3 to 2 ratio. 5 to 10 over 3 does end up being a 3 to 2 ratio. So that's our value for y. If I wanted to make that a decimal, I'd have to round. I'll just leave it as 10 to 3. So 5 to y is going to be that same 3 to 2 ratio. All right, now, in this diagram, using similarity. Now, I have to first be comfortable. I can tell you that these two are similar figures. This obviously is congruent to itself. This is congruent to itself. And they're telling me here that PS to PR is PT to PQ. So knowing that, I can then find out what the length of SR is. All right, so PS, which is 5, to PR, which is X, because I really don't know what this distance is, so I don't know what this whole distance has to be the same as PT, which is 8, to PQ. And be careful here, because PQ is 18. So it's a part to the whole, a part to the whole. Now, if I cross multiply, I get 8x is equal to 90. So 5 is to x as 8 is to 18. And x is going to then be equal to 90 over 8, which I'm going to simplify to 45 over 4. All right. So now I have found x, but let's be careful what we defined as x. We defined that whole side length, PR was x. See, x fit with PR. And what they're asking me to find is SR. So I know that SR is equal to PR minus SP. So SR is equal to PR, which I've solved for, 45 over 4, minus SP, which is 5, which I'm going to write as 20 over 4. And so I'm going to get as my answer for SR 25 over 4, and that is the distance of SR. All right, let's look at this diagram. I'm being told that DF to DH. So let's be careful again. DH is actually 21. So DF is 9, is to 21 as CE, which I don't know what it is to CG. Now be careful again. The way I'm defining CE as X, CG is now X plus 10. So when I solve this using cross multiplication, I have 9 times x plus 10 is equal to 21x. Then I distribute 9x plus 90 is equal to 21x. And I'm going to subtract 9x from both sides. And I'm going to get 90 is equal to 12x. And then I'm going to end up 90 divided by 12 is going to give me, I either can use a decimal here, and x would be equal to 7.5. I could use an improper fraction, say it's 15 over 2. So I have solved for x, and either one would be acceptable. All right, so scales. In a scale drawing, all lengths are proportional to their corresponding actual lengths. The scale is the ratio that compares each length in the scale drawing to the actual lengths. And the lengths used in a scale can be different units. And you can use proportions to find the actual dimensions represented in a scale drawing. So, for example, this diagram shows a scale drawing of the Golden Gate Bridge. It gives us the scale is 1 centimeter to 200 meters. If the length between the two towers in this diagram is 6.4, what's the length of the actual bridge?